We are all connected in lots of ways. Our friends, our families, our social media habits. We are constantly interacting with each other every day. But just because these connections exist doesn't mean we always see them. Like people, microscopic particles also interact constantly, pulling and pushing on each other as if connected by an invisible link. Consider a tiny microscopic brownie. This brownie is over 1,000 times smaller than a brownie crumb, and he lives in a world with a specific temperature, pressure, and volume. He's quite small, so the molecules that make up his world constantly crash into him, making his motion random and chaotic. Scientists call this random motion Brownian motion, named after the Scottish botanist Robert Brown. This discovery would later help us prove the existence of atoms, but that's for another video. Now our brownie brings some friends. They too experience Brownian motion, jostled around by the vibrating molecules that make up their world. But they discover something else. Each brownie pushes and pulls on all the other brownies, meaning they can interact. Between the medium and each other, these brownies in motion create a rather complex system. We wanted to know if it was possible to teach a computer how these brownies interacted with one another, simply by watching them move in a video. Could the computer identify how far apart they preferred to be? How strongly they repelled if they got too close? At what distance they no longer had an effect on one another? In machine learning, we build models that learn patterns and infer connections in data. To better understand what type of model we should choose to watch our brownies in motion, let's create an example. Let's say you're a teacher watching a group of children play at recess. Can you infer the relationships between the children just by watching them? Let's take a closer look. These children are sitting in a tight cluster spending time together. Perhaps they're friends and know each other quite well. These children, on the other hand, are spaced quite far apart. It seems they don't know one another at all. These children are running, and although are close together, they're still further apart than the group that was sitting together. It seems that if the speed of the children is larger, their average proximity increases. Interesting. A model that contains nodes, here the children, and edges, the connections between the nodes, is called a graph. So if we can build a graph where each node is a brownie, and each edge encodes how the brownie interacts with all the other brownies, perhaps we can teach the computer how our brownies interact. We start by making a prediction. Given where the brownies currently are, can our graph predict where they will be a split second from now? Our graph model doesn't know anything about our brownies yet, so this prediction is initially quite poor. The difference between our guess and the actual location of the brownies a split second from now is called our loss. We repeat this process of guessing and checking repeatedly, adjusting the parameters of our graph in such a way that hopefully our loss decreases. In practice, we choose a graph that has some physics pre-baked in for us. At the start, our graph knows that if we rotate the system or swap the brownies around, how the brownies interact with each other doesn't change. This is helpful because just 11 guess and checks later, our graph is really starting to get the hang of how these brownies interact. Now, we have to be careful. Like any AI, our model can make mistakes. Sometimes our models are quite good and predict how the brownies interact really well. Other times, the brownies completely outsmart the model, and our graph demonstrates a poor understanding of the brownies' interactions. Understanding why is tricky, but it's also a great reminder. Machine learning is a powerful tool, but it's not always right. Ultimately, we as humans decide whether a model performs well or not, meaning the best neural network for probing the universe and asking the big questions is still your brain.